Okay, we're recording. Appreciate y'all coming out early on a Friday morning. Is there anything y'all want to ask or any problems y'all want worked?
I don't have any specific problems, but could we maybe just like kind of go over it? Like, I don't care which problems, just some problems from this week's units, 7.1, 7.2.
Okay. And I guess we also need to talk about going around different lines as well. I remember leaving off with that on 7.2. We did not get around when it asked to go a volume around a different line.
Yeah, question 13 on 7.2.
Right. We left off. We did A and B, which were around the X and Y axis, and we didn't get to C or D. Okay. Can anyone point to a? You want to start with 7.1 first?
Sure.
Anybody want to see anything from 7.1? Put it up under the camera. Barely read it if it's down. They try to start with some easy ones by giving you the graphs. And we skip this section here, and then over here is where they we did a couple of those where you have to graph two of them, probably find intersection points, kind of the whole full problem.
Will we have to deal with the f of y? Because I know we went over it last time, but of the practice problems you had, none of them were in the grouping.
Why? Yeah, I probably didn't put any on the test. Oh, wait a minute, but you haven't seen the test for this yet. Yeah, more than likely, probably not any on the test.
Okay.
When the test hits in a couple weeks. Can we work any of these for anybody?
Sure. Could we do maybe one with a graph and then one without a graph, just to get like a taste of both?
Sure. Number 9 can get a little tricky. You want to start with that one?
Sounds good.
Okay. This is from 7.1, page 450, number 9. They give you a Y1 and a Y2 instead of F and G, I guess to get you away from the idea that F, rather than just blindly plugging in 3x cubed minus x in parentheses and 0, and they give you a graph. They're starting here, it peaks, goes through the origin, dips, and comes back up. And this intercept's -1, and this intercept is 1, and they want this. Okay, the generic formula we showed for area was the integral from an a to a b of an f of x minus g of x dx. And notice they did not label their formulas f and g, I guess just to get the idea across that they're just generic names. So what you do is you follow your logic, and this is the top curve and this is the bottom curve. Now, I hope they got across in Calc 1 that if I went ahead and did this whole thing from -1 to 1, I'll just set it up over here, -1 to 1 here, I would get 0 because the area here cancels the area here. The fundamental theorem gives you net area, your area on top or area left above the axis cancels area below. Okay, so that's not what we want. We actually want this physical number for both these areas. So what happens is we got to bust this into two pieces, into two integrals to get a number out. Because your top curve and your top curve switching, your bottom curve is switching. So I guess we can call this area 1, area 2. And so for area 1, you're going to run from -1 to 0. Your top curve will be the 3x cubed minus x, and your bottom curve will be 0, dx. And then you're going to add on an area 2 integral from 0 to 1, from 0 to 1, but your top curve is 0. Your bottom curve is your 3x cubed minus x dx. Now this is the full way to do it. If you're sharp, you can kind of notice or take advantage of symmetry. You could pick any one of these and double it, and you get the same answer. You could put a 2 and pick any one because this area here equals this area here, and you can play it that way. Should we pause for station identification to see if we've lost anybody? In both cases, I'm playing top minus bottom. Then switching here, this is top and this is bottom. That's why I picked this one, because a lot of people don't figure this out. They'll just run the whole thing and wait a minute, the area, I'm getting 0. And the answer isn't 0. Not getting any response. Did anybody want to ask about this, or?
I think we're good to continue.
Okay, do you want to actually see it punched?
Yeah, so do you just, from now on, you just put this, like you just plug it into the calculator and that's it?
Yeah, that's it.
Oh, okay.
We're not at all of the integrals in this chapter will be calculating numbers from integrals.
So basically this unit is setting up to punch it into your calculator.
That is correct, yeah.
Okay.
In Calc 1, I guess they made you work this out by hand with the fundamental theorem, get an antiderivative, plug in the top, plug in the bottom. We're kind of beyond that. We assume you know how to do that, and yes, we're just letting you use the calculator when you have numbers on the integrals for this chapter. Chapter 8, we go back to similar to Chapter 5. There will be no numbers on the integrals, and there's a bunch of techniques to find antiderivatives. That's probably the hardest chapter of the whole class. Except for Chapter 9. I guess 8 and 9 are the real heart, meat, guts, tough stuff of the whole class. Do you want to see this one punched?
Nah, I think we're good with that.
Because you could punch, the first one, add the second one. It'll probably fill the whole screen.
Yeah, that's just like, I don't think we need to see it punched in because that's just
All right.
numbers and stuff. Yeah.
Okay, sure thing. Any others from 7.1, or do you want to jump on to 7.2?
Could we do one, oh wait, no, never mind. Because all we need to do with the other type of problem without giving the graph is just graph it then, right?
That's right.
Yeah, okay then. I think 7.2, we can continue on unless anybody else has a problem.
Anybody else have another problem from 7.1? All right, so we'll jump to 7.2. Just to remind everybody, 7.2, all of a sudden I've frozen a little bit. Finding volume of solids revolution. Called it the disk method. I know you can't see what I'm writing because my screen is frozen. Maybe it'll come back to us here in a minute. I don't know if slapping the computer helps. Probably not. Slapping my phone. This is a shame. Okay, maybe we're coming back, hopefully. See if it'll catch up. Something moved. Okay, here we are. The two formulas, I really treat these problems like plug and chug. So around the x-axis, pi integral from a to b. I always use the full washer method. Minus g of x dx. Sorry, it's froze again. And around the y-axis, pi c to d f of y. Wish my screen would come back. dy. The logic is top minus bottom. Logic on this is right minus left. I don't know why my internet is gone flu wacky here. Worked fine during the first hour, 8 to 8:30. I did a pre-calc video. It was fine, but it wants to act up. I've quit writing. I get a great picture of my hairy knuckles. Great. Please, please. You think if we stop the share, we could bust it up and
I would assume.
maybe we could restart it and it might go better?
I'm guessing it's a bandwidth issue. Because like, are other people in your house using like also electronics that might require like connection?
Not at the moment, I don't think. My son usually starts school around 11 or so.
Oh, okay.
I could go ask him if he's even up yet. He's my technical assistant. I know my wife isn't. She doesn't get on till much later.
Okay.
She's up bustling around. I could see if my son's on and ask him to get off. And if not, I'll come back and maybe restart the whole thing, see if we can shake it up.
Okay.
No, nobody else is on it. Let me go ahead and stop the share and restart things and see if that'll bust anything up. Let me take the video off. I don't know if that'll help. Yeah, they can hear me. Okay, let's restart the share and see if it'll restart.
Let me do it.
I got it.
It's updating. Yeah, like we can see.
Okay. Okay, so that's what I wrote. There's the title of it. They call it. Okay, I've written DIS method generically, but I've written washer formulas. These are washer method formulas, which that's what I always use, because if I see the situation where my G is 0, if the curve goes all the way down to the x-axis, then my G equals 0, and I just throw away the G. Okay, did anyone want to see any specific one before we go around other lines? Because what happens is when you go around other lines, it's not directly the functions anymore. These have got to be modified, and there's no way to memorize a specific formula for it. It's specifically set up by the specific situation. This is hard enough in a regular classroom. I can't imagine being you guys and having to try to pick this up online. Thank God I never had to take any of this online. It didn't even exist, the tech in the 80s. The internet was, in its infancy. Nobody ever thought of trying to teach calculus online back in the 80s. That's how old I am. I'm a boomer. Does anybody want to see anything around the X or Y axis again, just to set up a formula like this before we blow your minds and go around other lines? So that's really from problems, problems 5, they give you graphs here through number 11, and then we got through 13A and B. Then 15A and B is, 15A is still around the x-axis, but then in B they switch to another line. They switch to a horizontal line. In 13C and D, they're doing vertical lines. Not getting much response. Does anybody want to see one similar to what we did last time before we?
Yeah, let's maybe like 15, question 15, was it?
Part A?
That had both. Yeah, that had, or we could just do the whole thing that had based on like around a line and also the x-axis.
Okay. 15A asks for an x-axis. And it's a real simple curve, just your standard parabola. So we're off page 461. This is 7.2. 15 part A, this is around the x-axis. And you're taking x squared and y equals 4x minus x squared. All right, hopefully you've got x squared memorized. That's your standard parabola. We don't have, unless you're a genius, 4x minus x squared memorized. So I'll put both of them on the screen. So x squared, 4x minus x squared. Oops, not going to work because I got that extra parentheses up on that line. I'll get rid of that. They didn't have graphing calculators when I took this stuff in my college. Down at Tech, they hadn't even been invented yet. Graphing calculators didn't come out till like the late 80s. Okay, I assume my window's fine. Yeah, okay, so graph. Okay, there's x squared. Okay, 4x minus x squared goes through the origin, curls up and down. So we're going to be interested in that part right there, which isn't shaded on the screen. That little connection. Get up there, yeah, if I can point to it. Right there between them, that little, I don't know what it's called there. Okay. The origin 0, 0 is clearly 1. We don't really have to find it, but we will need the x value there. So find the intersection point. Set your x squared equal to 4x minus x squared. Add the x squared over. 2x squared equals 4x. 2x squared subtract 4x would equal 0. Factor out a 2x, x minus 2. So your 2x would equal 0, therefore x would equal 0, and that's the origin point we already knew. And x would equal 2. So we know this point is at 2. All right, again, none of this is calculus. This is all algebra setup. I actually, on the test, try to minimize this by pretty much giving you a full graph, particularly when we were time tests in class, because you could spend 10 minutes graphing stuff, setting up algebra before you even get to the calculus. And you got an hour test. That's a lot of time to spend on non-calculus stuff. And we froze it again. Please, please, come on. Okay, maybe we're back. Maybe. Any questions about that setup? Not hearing anything, so we're going to plug into, and it's not writing. It's froze. Hate to keep doing this, but maybe I should stop the share and reset it up, see if it'll shake it. Having bandwidth issues this morning. Okay, let's no, it doesn't even want to bring in the okay, that worked. Okay, so anybody want to ask anything about this so far? We lost anybody? Can you all hear me?
Yeah. I don't think there's any more questions or any questions.
Okay. All right, so I'm going to write the formula again, the washer formula again. A to B, f of x, g of x, dx. Top minus bottom. All right, your top, that's the 4x minus x squared, the bottom facing parabola, and this is the bottom, which is your x squared. So the bottom is x squared and your top is 4x minus x squared. Have to go to the next page. You're going to run from 0 to 2. So that's going to plug in pi. 0 to 2. The top was 4x minus x squared. Bottom was x squared dx. You can plug it in as written. If you want to, do a little algebra in your head, realize that's a negative 2x squared. 4x minus 2x squared dx. Feel free. Pretty much the punch is kind of arbitrary. By the end of the chapter, we're going to have entries that are so complicated, you might want to simplify them before you enter them to even have the hope of getting the right answer. But, this isn't too bad. You really wouldn't have to do this. Anybody want to see this punched in?
No, I think that we can do that.
Okay.
It's pretty simple to punch it.
Punch in. Okay. Let me give you just a brief little lesson about other lines. Then, are we ready to charge into other lines?
Yeah.
Okay. Let me give you just a brief little thing because there's like 4 cases of other lines. I'm just going to zero in on x squared because it's really simple. And let's run from 0 to 2. From 2. And there's really 4 cases of other lines. Oh boy, I can't spell today. Sorry about that. Okay. The order you do these doesn't matter, but you can go horizontal line, above it or below it. You could do a vertical line. Let me just illustrate that. So you do an x squared, you could do a line down here, you could do a line up there. You could do a vertical line to the left or right. So in other words, you've got your x squared doing this, and you could do a line over here or a line over here. Around this, around this, around this, around this. If you read through the book, oh my goodness, I just suggested you read the book. Oh, horrible. The book actually also gives you a case where you can go around slanted lines, like a 45-degree line. Don't worry about that. We don't mess with that. I don't even know how to do it. We are going to stick to horizontals and vertical lines. This will be complicated enough. Okay, your first decision. When they give you another line, is this. Please don't freeze. A integral dx or an integral dy. Okay, here's how you decide. Back to the other, well, maybe I can just write it here. Remember, if you were going around the x-axis, basically you had an integral dx. X-axis is horizontal. So if you're given a horizontal line, and that's a y equals something, that is automatically a dx integral. Remember, if you went around the y-axis, You had an integral dy. Y-axis is vertical. Any vertical line will have a dy integral. This is very important because if you have an integral dx, everything in the middle must be in x or a number. And if you have an integral dy, anything in here must be in y or a number. Because it's really easy to get the letters crossed and use x stuff here when it has an integral dy, etc. All right, I know this gets very technical, but so let me lay out the cases here. Case one, we'll call case one, I'll stick to horizontals first. Let's call case one, horizontal line above. So I'm going to take x squared and anybody want to give me a number? It doesn't matter what number you use. I'm going out to 2. And I want to revolve.
7.
7. Okay, so he's calling out y equals 7. So we're going to go around y equals 7. So there's nothing up my sleeves. This is going to be an integral of a dx. The most general formula you can write down, well, let me explain what you got to be. When I did around the x-axis, there was one radius up, and it was called f of x. When you switch to other lines, you have to switch your point of reference to that line and draw radii in. There's 2 of them. You can start in and go to the outer boundary, and that would be called R, we use a little O for R outer. This stands for R outer. And you also start and draw to the inner boundary. That's called R inner. I'm out of paper up here, but you see this would mirror up here. I don't know if you can see this. This region would mirror up here, if I can draw a mirror of it, something like this. And you'd be really hollow in the middle. Y equals 7 is the center core, say, of the donut, and your outer shape has this shape on this side, and it have, a mirror shape up here. So there's an outer radius to it and an inner radius. And the most general, this is what I do with other lines, most general formula you'd have a pi, an integral r outer squared minus r inner squared dx. See, this pair before, it was straight f of x minus g of x, because those were the radii around the x-axis. But they're not anymore. I'm going around y equals 7. All right, we're still going to, I'll bring in the numbers on the integral here in a minute. Okay, well, how do you figure this outer radius? Well, basic college algebra, this is the y-axis. When I measure up from the x-axis, that's called y. When I measure forward from the y-axis, that's called x, because this is the x-axis. My line or graph has kind of gotten gibberish, so let me redraw it down here, try to make it clearer. If I'm going to go from 7 and do a distance down, the outer radius on this one is pretty simple. Can you see it's just 7? Because you're going straight all the way across here, you're going 7. Let's pause for station identification. Have we lost anybody? I'm taking the distance from that axis all the way to the outer boundary. It's almost like a rectangle. From here to here, it's a straight shot. It's all 7. So that's what plugs in here, 7 squared on this one. If you'd used 8, it'd be 8 squared. If you a little lower, it'd be, that number squared on this one. All right, the inner one, the total distance is 7. You got to go for this up from that axis, it's called y, and the total is 7. Let's call that r, inner. Y plus that inner radius is equal to 7. I'm trying to get to just this r inner from the 7 down to here. The rest of it is called y, r inner, and both of those add to this 7. So the r inner is 7 minus y. But I can't use y, it's a dx integral. Well, that curve, y equals x squared. So that's what I sub in, x squared. R inner is 7 minus x squared. And that is what goes here. 7 minus x squared. Should we pause for station identification?
Wait, where'd the so for RI, where'd the squared go? For like just in the main formula.
Okay, no, it hasn't gone. I'm just telling you what to plug in for RI.
Oh, okay.
Let me go ahead and finish, the formula. So the complete thing you got to punch in. You got a pi, you got an integral. You'd have 7 squared, because the r radius is just 7, goes in as a square, minus you'd have 7 minus x squared, quantity squared, dx. The last thing you need is the a and the b. That's determined by where the region is. And this one runs along x. These are x numbers. Got to be x numbers because of the dx. It'd be 0 to 2. And that's what you would punch in. And you can see how much more complicated the entries are getting if we actually made you do these by hand.
That one almost felt easier than the other ones.
Okay, great. Are you ready to shift the line below?
Sure.
Okay. Case 2, line below. Give me a number. Horizontal line below.
-2.
Okay. Line below. This is nothing. Same curve, x squared. Out to 2. Make it a round. Y equal -2. All right. Formula I'm going to use. Again, this is horizontal. Integral dx. I'm going to use pi integral r outer squared minus r inner squared dx. I hope it's obvious the inner radius is the easy one here. The inner radius is straight 2. You don't have to worry about it being negative because of the squares. Just do straight positive distance. From this line y equal 2 up to the inner part is like the length of the side of a rectangle. I mean, it's a constant 2. So that's going to be a -2 squared. Okay, the outer one I'll do the logic. I have to find our outer. That's our outer. This is the outer part of the region. Our outer. Okay, let's see. From the x-axis up, it's called y because you're parallel with the y-axis. Okay. You'd have 2 to here. So really on this one, it's 2 plus y equals your outer radius, or your outer radius is y plus 2. These can set up completely individually. You really have got to look at what you're doing, and you got to remember above the x-axis, it's called y. So this little segment is called y. The segment from the line up to the x-axis is a constant 2, just like the inner radius. So I'm going to have the r outer goes totally from there to there. So this one's going to go 2 plus your y, 2 here plus your y totals the r outer. And that's what you need. Except you can't use y because of the x on the dx integral. So this is 2 plus x squared equals the r outer. So that's going to plug in pi 2 plus x squared plus 2, either one, squared minus 2 squared dx. It still runs from 0 to 2. That's where the curve is. Let's pause for station identification. Anybody want to ask about that? Not getting any response.
I think that it was pretty clear. Like, so almost, I don't remember. Are we ever going to have to deal with 2 functions on the graph?
Yep.
We will?
Yep. That's why I'm trying to do a simple one. Yeah, you very, very well. In fact, fact 15b. Let me do these other 2 cases and then I'll go to 15b because that's going to be a case of 2 curves. Can I go on to these other 2 cases?
Yeah.
Okay. Vertical line to the right. Case 3, vertical line to the right. Vertical lines are x equals. Give me a number. There's nothing up my sleeves. 1 to 2, it's x squared.
5.
5. Okay, so we're going to go around x equals 5. See, that would mirror over here. You'd have kind of a donut shaped thing with a shape given by x squared on the edge given by x squared. It would mirror over here, and x equals 5 is the equation of the going through the center of the donut. If you wanted to see the on top would look like circles, etc. Okay, vertical lines. I'm going to set up a similar thing. You're going to have pi. Vertical lines are integral dy. Integral, I'm going to use a c to d because these are y numbers. Again, an r outer squared minus an r inner squared dy. Okay. First issue. You can't use this form. We've got to solve for y. Solve y equals x squared or y? Can you tell square root of y will equal x? Okay, so that'll get things in terms of dy. Your outer one, again, you start on a line and draw to the outer part of the boundary. That would be your r outer. Your inner one goes to the inner part. See, that kind of looks like a rectangle. That's the easy one here. Can you tell that's 3? Your 5 here minus 2, that distance has got to be 3. So that inner radius on this one is just a straight 3. The outer one is varying. Remember, forward it's called x. So to find r outer, you have x plus that r outer. This x plus that r outer has to total 5. R outer then is 5 minus x. Can't use x, it's a dy integral. What is x? That's why I did this. X equals the square root of y. So r outer is 5 minus square root of y. Plug and chug, pi integral 5 minus square root of y squared minus 3 squared dy. Now you got to go the integral limits. It's not 0 to 2. Those are x limits. It will be 0 though because it's going through the origin because y is also 0. But it's 0 because it's y, not x. So you will have y equals 0, which will be 0. And we got to find this. Well, if x is 2 up there, y is 4. So it will go from 0 to 4. Pause for station identification here. Have we lost anybody? We're in close to 50 minutes. Questions about that? You want to try the last case, shift the vertical line to the left? Not getting much response. You ready to shift the vertical line? Go ahead.
Sorry, I was muted.
Okay.
Yeah, we can do that. I just have a question. Will it be 5, or will it be negative if we use, for example, like -5? Would it be 3 squared minus 5 plus y squared, or square root of y? Just like calling it out, because I'm almost seeing a pattern with this.
There is a bit of a pattern, and yeah, it sounds right, but it's tough to do things orally. So let me write it down and see if it does work out that way. I think you probably are right. So you want to switch to case 4. Let's make it x equal -5.
Yeah.
Okay, so that'll put x squared. I'm getting 2. And we'll make it 1, 2, 3, 4, 5, -5. And again, that'll be an integral dy because this is vertical. I'll write it down, pi integral r outer square minus r inner square dy. Can you see the 0 to 4 doesn't change? This is y equal 4, 2 squared. This is y equal x squared, so it's 2 squared is 4. That doesn't change. That's where the region is. Can you spot the easy radius here? Going from his all the way to the outside of it. That's our outer. Can you tell what that is?
Yeah. So it'd be 7 squared.
7. Very good. Yep, that'd be 7. Again, don't get confused about the -5. I never bring in the -5. I just look. That's why it's so important to draw a picture. Just take it as a positive distance. You got 5 to here, and another 2 is 7. Otherwise, well, that's negative 5 too. Well, that's negative 3. No, that's not it. That's not what you want. Okay, you've got the inner radius. That's to the inside. Again, forward, it's called x. So what you have here is 5, your inner radius starts with 5 to there, and you're adding x. And then you're right, x is the square root of y, so your inner radius here is going to be 5, add the square root of y. I think you called that out. To give you some confidence in this, notice how it changes, that it's one distance here and it's a different distance up here. You can get the numbers and I can show you how it works out with the formula to give you some confidence with it. Maybe you can see it. The other diagrams got pretty complicated with the gibberish. It's hard to show, but look at it this way. Your R inner down here is 5 from here to here. You can check this at the extremes. Up here, it's 7. I'm sorry, let's see, R inner is 5 here. Yeah, your R inner up here would be 7. 5 here, and then 2 forward. All right, you can check it off the formula. If y is 0, which is this bottom, your R inner is 5 plus the square root of 0, which is 5. All right, this is at the bottom. All right, at the top, now your x is 2. Yeah, your y is 4, so you'd have R inner is 5 plus the square root of 4, which is 5 plus 2, which is 7. And you can see that off the graph. You're 5 forward and 2, so totally 7. I don't know if that proved anything to anybody or if that just added to the gibberish. Can we plug and chug?
Yeah.
I'd get pi integral 0 to 4. Your outer radius is 7 squared. And your inner radius is 5 plus the square root of y, quantity squared, dy. Questions about that? Are you ready to go to 15b? I guess we'll make 15b our last problem. We're closing in on an hour here. 15b's got the 2 curves, and it's going around a horizontal line of 6. Can we charge into that one?
Yeah.
Okay. Page 461, 15b. You had x squared and 4x. X squared, I did the graph just for speed things up. You had the parabola doing this, and the other curve did this. I'm leaving off the left side of the parabola. And doggone, wasn't it 2? Wasn't that, I guess I could flip back and find it. Wasn't that intersection 2?
Yeah, it was 0 and 2.
0 and 2, right?
Yeah.
Okay, and we're going to go around. Y equals 6. Right, that would be up here. We're up here, we have y equals 6. Okay, so that's horizontal. That would be an integral dx. Okay, this is going to be at 4. Can you tell that coordinate's got to be at 2 and 4? Because you're on x squared. This is x squared, and this is 4x minus x squared. Okay, so you can also plug the 2 in here. You get 8 minus 4, which is 4, yeah. Okay, volume equals, same formula I plug into, integral r outer squared minus r inner squared dx. try to use the same formulas every time. It's just a matter of plugging and chugging into them. All right, y is 6 is up here. That would be an outer, the outer radius would go to there. All right, so find r outer. Remember, forward up, it's called y. So r outer add y would equal 6. R outer is just to here. The rest of it's called y. Total 6. The r outer, 6 minus y. And in this case, to that curve, y is x squared. So that r outer is 6 minus x squared. I could check it at the extremes, if that helps. X is 0 here, and you can see it'd be all 6. So 6 minus 0 is 6. Then over here, x is 2. You can see the outer radius here is just 2. You're totally 6. You're up 4. This is 4. This would have to be 2. Your outer radius would be 2 right there. Tough to write all this down. It gets into the gibberish. Any questions about the r outer? Not hearing any. Are we ready for r inner?
Yeah.
Find r inner. It's the same idea in the procedure. Your r inner add y will total 6. So r inner is 6 minus y, but it's a different y. On r inner, your y is 4x minus x squared. This is confusing. So that is 6 minus 4x minus x squared. Because the inner radius goes to that inner curve, and the inner curve has that formula. Plugging in pi, plug in integral. You're back to 0 to 2 because you're in dx, 0 to 2. Outer 6 minus x squared squared. Inner minus parentheses 6 minus 4x minus x squared, close, close, squared, dx. See how much nastier that one is? You should be able to look this answer up in the back of the book. Should be able to punch that in and look up the answer in the back of the book. We're at an hour. Y'all want to take the time to punch that in and check with the back of the book, or do you think you can?
I'll punch. I can just punch it in right now.
Okay. I'll wait for you. You pretty quick? While
Not
you're
really,
doing that,
but-
I'll look up the answer in the back. This is the Mr. C idiot test. I've never worked these out in advance. I risk looking like an idiot. So this is, try to give you some confidence in this. 7.2 is problem 15b. Okay, 7.2, 15b. See, apparently the book, I want you to work it out by hand. 15b. The book has 64 pi divided by 3. If you work that, you realize how much longer you'd be here working that out by hand? You're probably 2 or 3 pages from the answer working that out by hand. Your calculator's probably not going to tell you 64 pi divided by 3, so I'm going to punch it. I'm getting 67.0206. You there yet, or are you still working away on it?
Oh wait, what was the answer? Like the number answer again?
67.0206.
Oh boy, I probably plugged in something wrong.
You want me to punch it?
Sure. There are so many parentheses that you have to deal with. It's
Yeah.
like,
This one, I would probably go ahead and simplify things a little bit. If it were me, 0 to 2, I'd probably FOIL this. So you'd get 36 minus 12x squared, add x to the fourth.
oh, I got it. I forgot to multiply by pi.
Oh, you forgot the pi in front.
Yeah.
Okay, so it worked out?
Yeah.
Okay. I probably would have foiled that. I would have simplified this and foiled that, maybe combined the terms down to a single polynomial and then punched it in. But like I say, if you got the patience and really careful with the parentheses, we're going to see entries a lot more complicated than this one too. Coming attractions.
Yay, how fun.
Yes, absolutely. Okay, we're at an hour. We can do a few more of these in the next Zoom meeting. Not Monday. Let's see, you guys are Tuesday, Friday. Yeah, so Tuesday at 9. We can do a few more of these if you want to see any more of this before we charge into the next week's sections, which I believe are 7.3 and 7.4. Anybody want to see anything or ask anything before we end the meeting?
Do you by chance know what test is going to be proctored?
No, I'm trying to do the next test so that we get it in before drop day.
So like this unit or like this unit's test?
Yeah, it'd be this unit.
Ooh. Okay. Yeah.
Chapter 7. Yeah, I think that'll be easier on you, trust me, than chapter 8 or 9.
Yeah, I'm definitely a fan because like this stuff seems a lot like I'm starting to understand this a good amount.
Okay.
So like I'm definitely, this one's good.
Okay. Yeah, I'd like to get that proctored because it's such a high percentage. That would give people a pretty good idea of a good grade before going into drop day, because it's 30% of your grade.
It's funny that like a test is almost double the final.
Yeah, they did that because finals coming at the end for everybody. The school does not have computer capacity to proctor finals for everybody. And so they decided to, make finals count a lot less because they're basically non-proctored.
Are the finals going to be like our tests, like what you did for the test that you let out yesterday?
All these format, yes. Quiz, test format, final format would be the same thing. You'll get a list of questions worked out. Some are right, some wrong. You go through and answer true or false, whether the problem is right or not, and put the answer on a Google form. The only difference between them, a quiz will cover material in the 1 week. Test covers material for the whole chapter, and the final covers material for the entire class. And yeah, you'll have review sheets for each test and for the final. Anything else before we end the meeting? Not hearing anything. People have gone silent. Anybody want to say anything? Or are we ready to end? All right, hearing nothing, I'm going to go ahead and end the meeting and hope you all have a good Labor Day weekend. Appreciate you coming out on a Friday morning. We'll have a next Zoom meeting, counting on it next Tuesday at 9 a.m. We'll try to keep the same schedule.
Thank you. Have a good one.
Sure thing. Same to you. See you then.